Are there infinitely many civilizations like ours scattered across the cosmos? Or are such civilizations extremely rare? Or is life elsewhere limited to simple microbial organisms that never evolved into the complexity we see on Earth? These are among humanity's most profound questions in our quest to uncover the true nature of the universe. Ever since we realized that the glittering objects in the sky are not angels or our ancestors, but stars like our sun, and as we came to understand first the vastness of our galaxy and later the immensity of the universe itself. Before we can even begin to answer these questions, the first and most crucial step is to understand our own world. We need to study in depth the features and conditions of Earth, the precise combination of factors that allowed life to originate here and that continue to sustain it today. By identifying these conditions, we create a foundation for recognizing where else in the universe such life-supporting environments might exist. Our planet exists within a delicate balance of conditions that not only allow life to exist, but also nurture its incredible diversity and complexity. One of the most important factors that makes Earth so special begins not here on the ground, but far beyond, with the position of our parent star, the Sun, within the Milky Way galaxy. The Sun's location is in what astronomers sometimes call the Galactic Habitable Zone, a relatively calm and safe neighborhood compared to other, more dangerous parts of the galaxy. It is neither too close to the galactic center nor stranded on the far edges. The inner regions of the galaxy are densely packed with stars, massive black holes, and high-energy events, making them hazardous for the long-term stability of planetary systems. On the other hand, the far outer edges may lack the heavier elements needed to form rocky planets like Earth. Our Sun sits somewhere in between, in a stable mid-region, and more specifically, between two major spiral arms of the Milky Way. This location is like living in a quiet suburb rather than in a bustling, chaotic city center. Here, stars are spaced farther apart, which means our solar system is less likely to experience close encounters with other stars that could disrupt planetary orbits. Adding to this stability, the Sun's orbit around the center of the galaxy is almost perfectly circular rather than elongated or highly elliptical. This consistency helps avoid wild swings into dangerous regions of the galaxy over millions of years. And because there are relatively few massive stars in our immediate cosmic neighborhood, the chances of nearby supernova explosions or deadly gamma-ray bursts are far lower than in more crowded regions. This safe, predictable galactic environment has been critical for Earth. It has shielded our planet from many cosmic dangers, allowing life not only to take hold but to evolve peacefully over billions of years without frequent catastrophic resets. In this sense, our location in the galaxy is not just a matter of coincidence. It is one of the foundations of our existence. Before we go ahead with the topic, I have a request to everyone who is watching. This is the first video on the channel and I would need all your support in making such videos in the future. After you watch this video, please share your thoughts in the comments and leave a like for the YouTube algorithm. Please also share in the comments where you are watching this video from. It gives me immense satisfaction to hear from the amazing human beings who are equally fascinated by our universe and how it functions. Life on Earth, as it is known, is dependent on water. Each star has its own Goldilocks zone around it. This zone, not too close and not too far from the parent star, creates the perfect temperatures for water to remain liquid. Earth happens to be in the Goldilocks zone of its parent star. This unique position, combined with our atmosphere, keeps water in its liquid form at Earth's surface, where it is essential for life. If Earth were closer to the Sun, water would boil away too far and it would freeze. It's this balance in the Goldilocks zone that allows Earth to maintain liquid water, a necessity for life. This delicate range is not only necessary for water but also for other vital processes such as photosynthesis, which forms the foundation of most food chains on Earth. Water is often described as the universal solvent because it can dissolve a wide variety of substances making it an essential medium for chemical reactions. Water is also the environment in which life forms, from the smallest microorganisms to the largest animals. It's the solvent for all chemical reactions that sustain life, and it has a unique ability to remain in liquid form across a broad range of temperatures. On Earth, liquid water remains stable due to the planet's temperature range, allowing it to play a key role in processes such as metabolism and nutrient transport. Water may be essential for life, but it is not enough on its own. What truly sets Earth apart is its atmosphere, a dynamic shield and life support system that works in harmony with the planet's other features to make complex life possible. While Venus and Mars are often said to lie within the Sun's Goldilocks Zone, where temperatures could, in theory, allow liquid water to exist, neither world enjoys the same life-sustaining balance as Earth. Venus, shrouded in a dense atmosphere of carbon dioxide, suffers from an extreme greenhouse effect, turning its surface into a furnace hot enough to melt lead. Mars, on the other hand, has an atmosphere so thin that it cannot hold on to heat, leaving the planet cold, dry, and exposed to deadly radiation from space. Whether either of these planets once hosted life or perhaps still harbors microbial life in hidden pockets remains an open question for science. Yet the lesson they offer is clear. A planet's position in the habitable zone is only part of the equation. Without the right kind of atmosphere, one that regulates temperature, shields the surface from harmful radiation, and supports a stable climate over billions of years, life struggles to gain a foothold, let alone flourish. Earth's atmosphere is made up of a special mix of gases, mainly nitrogen and oxygen. Oxygen is vital for respiration in many life forms, enabling them to extract energy from food, while nitrogen is a crucial component of proteins and DNA, the molecules that form the foundation of all living organisms. Earth's atmosphere has a natural greenhouse effect. This is the mechanism that traps heat from the sun, preventing it from escaping into space and keeping Earth warm enough for liquid water to exist. Without this greenhouse effect, Earth would be a frozen wasteland. The atmosphere also helps to distribute heat across the planet, preventing extreme temperature fluctuations between day and night. But it's not just about warmth. Oxygen is also vital for the formation of ozone, which protects life from harmful ultraviolet radiation. Without it, Earth's surface would be bombarded with radiation so intense that life would be impossible. The ozone layer, therefore, plays a critical role in safeguarding life by reducing the amount of ultraviolet light reaching Earth's surface, preventing cellular damage and genetic mutations that could disrupt life's processes. Earth's magnetic field is just as crucial for sustaining life. Generated by the planet's molten iron core, Earth's magnetic field acts as a shield, deflecting harmful solar and cosmic radiation that would otherwise strip away the atmosphere. This magnetic field is a result of Earth's rotation and the movement of liquid metal within its outer core. Without this protective field, the sun's radiation could destroy Earth's atmosphere, making life unsustainable. In fact, this is one of the reasons why Mars, which lacks a magnetic field, is no longer habitable. Without a strong magnetic field, Mars was unable to retain its atmosphere, and over time, its water evaporated, leaving it cold and dry. Earth's magnetic field, therefore, is not only a defense against solar winds but also a key factor in maintaining the stability of our atmosphere and supporting the presence of liquid water on the surface. Now, consider Earth's plate tectonics. This is one of the most underrated factors when it comes to sustaining life. Earth's surface is made up of tectonic plates that are constantly moving. This movement creates volcanic activity, forms mountains, and most importantly, regulates the carbon cycle. Volcanoes release carbon dioxide, a greenhouse gas, into the atmosphere. This helps regulate Earth's temperature over long periods of time by controlling the amount of carbon in the atmosphere. Without tectonic activity, Earth's climate could fluctuate dramatically, potentially making it uninhabitable. For example, if carbon dioxide were to accumulate too much, it could lead to runaway greenhouse effects, making Earth unbearably hot. Conversely, Without the release of carbon, Earth could cool and enter a freezing phase. Plate tectonics also help recycle nutrients, bringing minerals from Earth's interior to the surface, which supports the growth of life. The recycling of minerals such as phosphorus and nitrogen through the tectonic cycle supports soil fertility, enabling plant life to thrive and sustain entire ecosystems. The carbon cycle, which moves carbon through Earth's atmosphere, oceans, and living organisms, ensures that the elements crucial for life are available in the right amounts. This delicate balance is what makes Earth's chemistry so well suited to support life. The interaction between living organisms and their environment, such as the uptake of carbon dioxide by plants during photosynthesis, plays a vital role in maintaining this balance. When carbon is sequestered in plants, fossil fuels, and sediments, it helps regulate the amount of greenhouse gases in the atmosphere, preventing runaway climate change. Earth's size is another overlooked but essential factor. Unlike the gas giants of the outer solar system, Earth is just the right size to retain a thick atmosphere. Larger planets, such as Jupiter, have strong gravity but are inhospitable, and smaller planets like Mars struggle to retain their atmospheres. Earth's size allows it to maintain the right mix of gases, temperature, and pressure to support liquid water and, ultimately, life. If Earth were much larger, its gravity would be so intense that it could retain an atmosphere of gases that are toxic to life. If it were smaller, the atmosphere could be too thin to protect the surface from harmful solar radiation or retain enough heat for life to exist. Earth's size, therefore, allows for a unique balance between atmosphere and temperature, two critical elements for sustaining life. Let's shift gears for a moment. Now, look outward into the solar system, and the role that Jupiter plays in protecting Earth becomes evident. Jupiter's massive gravity acts as a protector for the inner solar system, capturing or deflecting asteroids and comets that might otherwise collide with Earth. Jupiter's gravitational field acts as a cosmic shield, preventing these objects from reaching Earth, which has experienced catastrophic impacts in the past. These collisions could have wiped out life or significantly altered Earth's environment. In addition, Saturn helps stabilize Jupiter's orbit, ensuring it doesn't migrate inward and disrupt the inner planets' orbits, including Earth. Without this cosmic stability, Earth's orbit could shift, leading to environmental chaos. Jupiter and Saturn's gravitational influence, therefore, have a stabilizing effect on the entire inner solar system, including Earth. Neptune, often overlooked in the story of life on Earth, acts as a distant gravitational guardian of our solar system. Its immense pull scatters and redirects countless icy bodies and rocky debris in the Kuiper belt, preventing many from drifting inward toward the inner planets. By keeping much of this material confined to the outer regions and working in tandem with Jupiter's own defenses, Neptune reduces the frequency of catastrophic impacts that could have repeatedly wiped the slate clean on Earth. This quiet, long-term protection has helped maintain the stability needed for life to not only emerge, but also to evolve into the rich complexity we see today. And then there's Earth's moon. The moon's gravitational pull creates tidal forces that affect Earth's oceans and atmosphere. These tides play a crucial role in stabilizing Earth's climate by redistributing heat across the planet. These tidal forces also provide important ecological functions such as nutrient cycling and the regulation of marine ecosystems. The moon's influence has also been critical in the development of life, particularly in regulating Earth's axial tilt, which affects seasonal variation. The presence of the moon helps maintain a comparatively stable axial tilt, preventing extreme shifts in climate over short periods. The presence of the moon has, therefore, been a stabilizing force, contributing to the long-term habitability of Earth. Earth is tilted on its axis by about 23.5 degrees, and this tilt is the reason we experience seasons. As the planet makes its year-long journey around the Sun, each hemisphere tilts toward or away from the Sun for about 6 months at a time. This means that when it is summer in the northern hemisphere, the southern hemisphere experiences winter, and 6 months later the situation is reversed. Near the poles, this effect is even more dramatic. regions plunge into weeks or months of continuous darkness, only to emerge into equally long stretches of sunlight. The Earth's axial tilt is not constant. Over a 41,000-year cycle, the tilt gradually shifts between 22.1 and 24.5 degrees. Additionally, over a 26,000-year cycle, the Earth experiences a wobble on its rotational axis, similar to a spinning top. This wobbling causes the Earth's axis to trace a circular path in space, leading to changes in which star appears as the North Star, as well as shifts in the positions of the celestial poles and equinoxes. Earth's orbital eccentricity, which measures the ellipticity of its orbit, also changes due to the gravitational pull of other planets, particularly Jupiter and Saturn. This cycle lasts approximately 100,000 years, with eccentricity fluctuating between a nearly circular orbit, eccentricity of 0, and a mild ellipse, currently around 0.0167. These cycles, known as the Milankovitch cycles, describe the combined effects of changes in Earth's movements on its climate over thousands of years. These subtle changes alter the distribution of sunlight across the globe and have played a crucial role in triggering ice ages. Together, these short-term seasonal shifts and long-term climatic rhythms have created a dynamic and ever-changing environment, one that has both tested and inspired life, shaping the course of evolution on our planet. A planet's rotation is far more than just a spinning motion. It is the engine that creates a regular day-night cycle, a rhythm that has shaped life on Earth for billions of years. This predictable alternation between light and darkness has been essential for the evolution of biological clocks or circadian rhythms in nearly all living organisms. These internal timekeepers regulate sleep, feeding, reproduction, and countless other processes, helping life adapt to the changing conditions of each day. One of the most important benefits of this cycle is its support of photosynthesis, the process by which plants, algae, and some bacteria convert sunlight into energy. Without the balance provided by a rotating planet, such processes could be severely disrupted, and the diversity of life we see today might never have emerged. Planets like Mercury and Venus experience a very different relationship with the Sun compared to Earth, especially when it comes to the concept of a day. Their rotations are much slower, making their day lengths vastly different from ours. On Mercury, one full rotation takes about 58 Earth days, while on Venus, a single day lasts an astonishing 243 Earth days, even longer than its year. On Mercury, one side of the planet faces the Sun for an extended period, baking under intense heat, while the opposite side remains in prolonged darkness, plunging into freezing cold. Venus, though not completely tidally locked, still rotates so slowly that its days and nights stretch on for months, allowing heat to build up to scorching, inhospitable levels. Such extreme and prolonged temperature differences make it nearly impossible for a stable climate to form. And without climate stability, the development and sustenance of life as we know it becomes highly unlikely. These worlds remind us that a planet's distance from the Sun is not the only factor in habitability. The speed and pattern of its rotation also play a critical role in creating conditions that can nurture life. Together, all of these factors, Earth's position in the Goldilocks Zone, liquid water, a stable atmosphere, magnetic protection, plate tectonics, and many others, work in harmony to create an environment where life can not only emerge but also persist and evolve over billions of years. These features, which work together in an intricate balance, make Earth an incredibly precious oasis in the vastness of space. Life on Earth evolved in relation to Earth's own features. The conditions on Earth created opportunities for life to form and adapt, and life evolved through those conditions, not because of them. Life, as we see it on Earth, might be unique to our planet, and life on other worlds might look and have evolved differently than on Earth. The features seen on Earth, from liquid water to a stable climate, are products of natural processes that gave rise to the possibility of life, which then adapted to those conditions over time. The features of Earth and the life it supports have evolved together, shaping one another in a dance that has lasted billions of years. They are intertwined, each influencing and adapting to the other. The interconnectedness of life and Earth's features creates a dynamic relationship, one that has led to the thriving ecosystem seen today. As the search for life beyond Earth continues, the question remains, could life elsewhere in the universe thrive under different conditions? Or are the features of Earth truly unique in supporting life as we understand it? As exploration of the cosmos progresses, this mystery may eventually be answered, but for now, Earth remains the only known planet where life, as it is understood, has emerged and flourished. Share your thoughts below. Welcome to Sagacity section. Thank you for watching, and I'll see you in the next one.